Welcome to lesson number 1 on radicals. So today we're going to look at what entire radicals are and what mixed radicals are, and of course what radicals are in general. The nice thing is you know what radicals are already. You've looked at them since grade 8 probably, but it probably wasn't until grade 10 that you started referring to them as radicals. So if you remember square roots, cube roots, and other roots, like fourth roots and fifth roots, then what you're doing is you're working with radicals. So for a square root, remember that all positive numbers have two square roots, so a positive and a negative number. And the positive square root is called the principal square root. And we use this symbol, our radical sign, in order to show a square root. And the square root of a perfect square, they are rational numbers. Alright, so the square roots of 16 are 4 and negative 4. But note that if we're taking the square root of 16, it can only be 4. Only 4. So the square roots of a non-perfect square are irrational numbers. So square roots of 17 are square root of 17 and negative square root of 17. But if you were to plug that into your if you're going to plug that into your calculator, square root of 17, you're going to get an irrational number. So a number that cannot really be represented as a fraction. Now we have cube roots. So all numbers that are positive and negative have one cube root, denoted by the symbol cube root. So the cube root of a perfect cube is a rational number. So for example, the cube root of 1,000 is 10, and it would look like this: cube root of 1,000, and that's equal to 10. The cube root of negative 27 is negative 3. This is a perfect cube, and the cube root of negative 27 would be negative 3. But notice that we had the cube root of negative 27. You can't take the square root of a negative number. So square root of 16 was only positive 16. That could be equal to 4 or negative 4. But notice how that the cube root of negative 27 still gives us negative 3. We still get an answer out of that. The cube root of 49 is cube root of 49. So this is not a perfect cube, right? So the cube root of a non-perfect cube is an irrational number. So again, if we were to go to our calculator, use the math button, and choose option 4, and then type in 49, we're going to get an irrational number, a number that cannot be represented as a fraction or terminating decimal. So let's complete the statements below. So, other types of roots. The fourth roots of 16. Now, if you're wondering, now this is one that you should know first of all, but if you're wondering how you would input this into your calculator, I would go to my math button right here, and I would go down to option number 5. Now, before I even type in that, I want to tell my calculator I'm looking for the fourth root, and then I would put in 16. And I would get an answer of 2. So the fourth roots of 16 are 2, and since this is an even number, it's also going to be negative 2. So negative 2 times negative 2 times negative 2 times negative 2 is going to give me 16. The fifth root of negative 32, well, this is negative 2. And again, if I want to find out what that is, I put in that 5 for fifth root, go to my math button, option 5 right here, or you can just press 5, press enter, and negative 32. I get negative 2. The only reason I can input a negative value here is because my index is also not an even number. So let's move on to class example number 1. Without using a calculator, evaluate these where possible. So square root of 64, that is equal to 8. So 8 times 8 equals 64. This is not possible. The reason I know it's not possible is because we have an index of 2. It's an even index with a negative inside. So that's not going to be able to be calculated. The cube root of negative 64, that's equal to negative 4. So negative 4 times negative 4 times negative 4. The fifth root of 1 over 32, or 1/32, is equal to 1/2. the reason I know, and so I should put my equal signs. The reason I know this is 1/2 is because I know that the if I were to just take the 5th root of 32, that's equal to 2, because 2 to the power of 5 equals 32. So if I have my numerator is 1, I can just solve for my denominator, leaving my numerator on top as 1. Again, this is not possible, the 4th root of negative 16, because we have a even index. So 10 times the cube root of 125, this would just be 10 times 5 times 5 times 5, or 5 is equal to 10 times 5, 50. Right, so again, I encourage you to pause these videos, go back, and make sure you know how to solve these types of problems. And so just a recap, what the square root of 64 is asking me is if I have a perfect square, 64, what number would make up a side of that square? And that would give me 8 here. Alright, so moving on to using this feature in the calculator. This is something that we have looked at already, and hopefully you already know how to use this feature in your calculator, but if you don't, that's fine, because we are, I'll just go over it again. So what they want us to look at is use the following procedure to determine the 4th root of 10,000 on a calculator. So how do we actually walk through that? Well, first let's press our 4 button. Alright, so first press the 4 button. So I've pressed 4. Now press the math button. Alright, so I press the math button. Now 3, choose option 5. So option 5 is this one I showed you previously. I press enter. Now I press 10,000 and press enter, and I get my answer of 10. The answer will be 10. Look at that. So now what they want us to do is use our calculator to determine the exact value of each of these in class example number 2. So first, 5th root. So I press 5. I don't press 4 because I'm looking for the 5th root. Choose option 5, 2, 4, 3. Enter. The answer is 3. 7th root. Option 5, negative 16,384. Press enter. I get an answer of negative 4. And last, you don't really need a calculator for this one, but you can use it for this one and they want exact values, so they don't want they want all their answers to be in fractions. The final answers they want in fractions. So this, we could rewrite this one here as cube root of 125 divided by the cube root of 216. And if I do that, I can solve these separately. And we, instead of going 3 math button 5, we can just choose option 4 because we're looking at the cube root. So 125, I get 5 right there, over 216, 5 over 6. Next, let's move up to example 3. Example 3, we want to solve to the nearest hundredth. And again, we're going to be using the calculator for this one, so we're looking for the 5th root of 500, so 5 math, option 5, and I type in 500 here. And nearest hundredth, so 2 decimal places, 3.4, round that 6 up, because of this 5, round this 6 up to 7, 3.47. Next, I'm working with the 6th root of 0.6, so 6 math, option 5, 0.6, nearest hundredth, so 2 decimal spaces, round that 1 up to 2, and we have 0.92. Next, I have 2/5 times 4 to the power or sorry, fourth root of 100. So bracket 2 divided by 5, bracket, close that bracket, fourth root of option 5, 100, close the bracket, and we get 1.26. Don't need to round up. Nearest hundredth, so 2 decimal places. So again, if that was confusing, pause here and then rewind and rework those problems. Now, we are working with radicals. And so just a quick review of radicals again. Numbers like square root of 30, cube root of 125, fourth root of 15, sixth root of 1 million are examples of radicals. And what they have in common are these radical signs here. Right? So if a number has a radical sign on it, it's a radical. So any expression of the form nth root of x, outlined like that, where n is a natural number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all natural numbers, that is called a radical. The value of n is the index, and so a number like square root of 30, even though it doesn't show the index is going to be 2. All right, so square root, any number that's got a square root, this index is 2. X, so the value in this case 30, that would be my value of x. That's the radicand, and this sign here that you've been seeing since grade 8, that is my radical sign. So if the index in a radical is even, then the radicand must be positive. All right, so here I have my index is 3. So index is 3 there. My radical sign is not any different than what you've seen it before. And my radicand would be 29. The whole thing is referred to as a radical. All right, so this whole thing, if you look at it as one piece, is known as a radical. So if you don't see an index, that means that the index is 2, even though it's not shown. So how do we combine radicals? So if I have 2 radicals, and I kind of showed you when we were dividing how it looks, but what if we're multiplying, or what if we're adding or subtracting? So first of all, we want to verify these calculations. So square root of 9 times square root of 4 is equal to square root of 9 times 4. Well, let's see. Square root of 9 times square root of 4. And we get 6 because square root of 9 is 3 and square root of 4 is 2. So 3 times 2 is equal to 6. So do I get the same thing when I go square root of 9 times 4? See the difference there? This one I've separated my my radicands into 2 separate radicals. Now I have one radical with 2 radicands, and I get the same answer, 6. So this is equal to 6. Now, what if I do this? Square root of 9 plus square root of 4, square root of 9 plus square root of 4, I get 5. But how about square root of 9 plus 4? I get a completely different answer. So these are not equal. However, the square root of 9 divided by the square root of 4 is equal to the square root of 9 divided by 4, kind of just like what we saw in one of the previous examples. All right, so you can go ahead and you can test that, but what you're going to end up getting is square root of 9 is 3 divided by 2, so 3 halves is 1.5. You should get the same answer when you do that. And then when you're subtracting radicals, you're going to find that if you have 2 separate radicals and you subtract them, it's not the same thing as subtracting one radical with different radicands. So what we have are product and quotient of the roots. And so I'd encourage you to read this, but the product or quotient of the roots of the 2 numbers is equal to the root of the product or quotient of the 2 numbers. So what we're going to do is we're going to look at class example number 4 now. We got to state whether each statement is true or false. So if I have square root of 3 times square root of 5, and that gives me square root of 15. Well, if I look at this previous example, and in general, this previous example is summed up right here. And I'm going to highlight this in green, actually. This is important. So this is something that you should remember. So the square root of a times square root of b is equal to the square root of a times b, where a and b have to be greater than or equal to 0. And similarly, the square root of a divided by the square root of b is the same thing as the square root of a divided by b. So let's see how they get this. 15. So square root of 3 times square root of 15 would be the same thing as saying square root of 3 times 5. 3 times 5 is the square root of 15. So that is true. Square root of 30 divided by square root of 10. Well, if I have the square root of 30 divided by square root of 10, that's the same thing as saying the square root of 30 divided by 10, and 30 divided by 10 is 3. So that's also true. Now this is the one that we looked at over here, and that's not the case, right? Because the square root of 16 plus 9, we're going to get 25. That's going to be 5. But square root of 16 is 4, plus square root of 9 is 3. So I get 5 is equal to 7, which is not at all true. Now let's move on to, if you want, you can pause the video and you can attempt some of these questions, or you can continue watching and we'll look at entire radicals and mixed radicals. Alright, so use a calculator to approximate the value of each radical to 5 decimal places. Alright, so they want us to bust out the calculator here. Square root of 96 to 5 decimal places. I'm gonna get 9.79795, but round that up to 6. 2 times the square root of 24. Notice how, when I wrote this, I didn't actually put a multiplication sign, and that's okay. But I get the same answer. 9.79796. And last I have 4 root 6. And I get the same answer again. 9.79796. So I have 3 different ways to write this radical, and I get the same answer every time because they're the same answer. So what do you notice about them? They are the same answer. So complete the following to explain why the 3 radicals are equivalent. Well, square root of 96 is equal to square root of 4 times 24. And remember, we can separate this into 2 radicals by saying that's the square root of 4 times the square root of 24. Now, one of these is a perfect square, and that's my square root of 4, of course. Right, that's a perfect square. So we know that the square root of 4 is 2, so we can rewrite this as 2 times square root of 24. This would give me an irrational number, so I can just leave it as square root of 24 for the exact value. Now how about here? Square root of 96 we can say is square root of 16 times 6. Well, again, we can separate that into the square root of 16 times the square root of 6. And if we did that, we're going to, again, be left with a perfect square. Square root of 16 is a perfect square. And that would give me an answer of 4 root 6. But as you notice, these are all going to equal the square root of 96, which is why they're similar. So, well, they're not similar, they're the same. So the square root of 96, what that is an example of an entire radical. All right? So square root of 96, that's my entire radical. So the whole number is entirely under the root symbol, or under my radical sign. 2 root 24 and 4 square root 6 are examples of mixed radicals where we have part of the number outside of my radical sign. So 4 is outside of the radical sign, and 2 is outside my radical sign. Yeah, so now let's look at some examples. So entire versus pure radicals, these are just rules to remember. What you should do is just pause and make sure you read through these and just highlight these examples. But I'm going to keep going with the video so it doesn't end up being too long. But how do we convert, like we did last time, an entire radical to a mixed radical? So this time what we want to do is we want to convert this entire radical, square root of 72, into a mixed radical. So 72, if I'm saying that part of it is made up of 2, that means that there's 2 other pieces that would make up this 72, and or 2 pieces of 36. So 2 divided by 72 would give me 36. Square root of 36 times 2 can be written as the square root of 36 times 2. Now 36 is a perfect square, which is what we're looking for. The square root of 36 is 6. So we could say that 72 is equal to 6 root 2, or 6 square root 2, or 6 times the square root of 2. An entire radical of index 3 may be expressed as a mixed radical when the highest perfect cube has been factored out. So this is key here, this point here. The highest perfect cube needs to be factored out of the entire radical. So here's my entire radical, cube root of 108, and I want to find a perfect cube. So we see that there's a 4 that's already been taken out of that, so 108 divided by 4 is going to leave us with 27. Now remember, we can rewrite this as the cube root of 27 because we started off with a cube root to begin with, right there, cube roots everywhere. And so cube root of 27 is going to give me 3. I end up with 3 times the cube root of 4, or 3 cube root of 4. Make sure you include this cube root right here. Okay, this is very important. Let's do a couple of these examples. I don't want this video to end up being too long, and I'll end up splitting this into 2 videos, but let's look at how to solve these. So we're putting these entire radicals into mixed radicals. So if I have the square root of 320, here's a trick. If anything ends in 0, we can divide by 5 or 10. So let's start by dividing by 5. So 320 divided by 5, we're going to get 64. Right away, I'm at a perfect square, and that's what I'm looking for, right? So I could say that's the square root of 64 times 5. Or I could say that's square root of 64 times square root of 5. Square root of 64 we know is 8, and times the square root of 5 is my final answer. Again, if we're ending in, well, here's another trick. If you have anything that's divisible by 1,000, just divide by, in this case, 6. And so cube root of 1,000, because 1,000 is a perfect cube, times 6, which we could say is the cube root of 1,000 times the cube root of 6, or cube root of 1,000 is 10 cube root 6. So this one here, 5th root of 486. So let's start by just dividing by 2. Sometimes that also helps. If you divide something by 2, so we end up with 243. And as you go along with these types of questions, you'll start to notice patterns. And you'll just come to recognize some of these common numbers that you know are perfects, in this case, a perfect 5th. And so 243, we could take the 5th root of that, and I would get 3 times the 5th root of 2. I know that 2 is not divisible by 5. And this last one, 2 times cube root of negative 40. So negative 40, let's go divide by 5 is negative 8 times the cube root of 5. Cube root of negative 8 is going to be negative 2 times the cube root of 5. 2 times negative 2 is going to give me negative 4 times the cube root of 5. And that is my final answer here. And I'm going to end up making another video just to do this last example.